Adding rational expressions. To add a rational expressions, basically fractions, um, we're going to have a least common denominator. Right now, let's look at our denominators. Our denominators are, well, we have a 3 and a 2. So what will happen with the 3 and the 2 is that you go through the multiples. So the multiplications of 3 is 3, 6, 9, and 12. The For 2, the multiples are 2, 4, 6, and 8. So what they have in common is the 6. So what do you have to multiply 3 times to get the 6? You have to multiply by 2. But whatever you do to the denominator, you also have to do to the numerator. So there's a times 2 there. How do you go from a 2 to a 6? Or turn a 2 into a 6? You have to multiply by 3. 2, 4, 6. So that's times 3. But what you do to the denominator, you do to the numerator. So what's going to happen is that we're going to get a denominator of 6 in both cases. The numerator here will be a 10. The numerator here will be a 9. Okay, so let's take a look at that. So we have a 5, a 3, a 3x to the 4th, a x plus 3 to the 7th power. Here we have a 2x squared and an x plus 3 to the 6th power. All right, so let's see if we can get those common denominators going. So in the multiples of 2 and 3, for the 5 and 3, 5 and 3. So for 3, what turns that into a 6 would be multiplying by 2. So we're going to multiply by 2, and that's going to turn, and together that's a 6. But what do we do to the denominator? Have to do to the numerator, so times 2 as well. Now for the x's, you have an x to the 4th here and an x to the, I forgot I gotta go over here. So we have a 2 here, and we want that to be a 6. So how to make that a 6? You have to multiply by 3. And what do we do to the denominator? You also do to the numerator, so times 3 again. Okay, now everything is matching. Okay, furthermore, we have x to the 4th here, x to the 2nd here. The x to the 4th is the LCD, least common denominator, so x to the 4th and x to the 4th. And finally, you have an x plus 3 to the 7th and an x plus 3 to the 6th. The highest power will be your least common denominator. So x plus 3 to the 7th here, and then parentheses x plus 3, kind of running out of room to the 7th power here. Okay, kind of bleeding over. Okay, so let's find out what that wonderful new denominator is. The denominator will be 3 times 2, that'll be 6 x to the 4th. Over here, x plus 3 to the 7th. X plus 3 to the 7th power. Okay, and we never got our new pieces, because you have an x squared there and an x to the 4th there. There's 2 extra x's, so I have to put 2 extra x's there. And we have x plus 3 to the 6th, and here x plus 3 to the 7th. And there's one more extra x plus 3. Okay, sorry, I didn't put that. Here there's nothing extra. All right, so the 5 times 2, that's a 10. And then the plus. Now, 3 times 3 times x squared has to be multiplied with the x, because all of this is to the first power, so we can do a distribution. So again, here we go. 3 times x squared times x. The 3 times 3 is 9, and whereas the x squared times x gives you x to the 3rd power. Another distribution. Let's go to the 3. We have 3 times x squared times 3. Okay, 3 times 3 times 3. I know that's 9 times 3 is 27. So that's going to be a 27 and then x squared. So plus 27 from 3 times 3 times 3, x squared. And we're finished. Okay, next one. Let's hope we don't run out of room here. This is going to be a numerator of 4 and 1, and the denominator is 5x squared and an x minus 7, and that's to the third power. Here you get a 6x third power, x minus 7, and that's to the second power. So let's find the least common multiples. Put the 4 and the 1 out of the way, over here to the side. Okay, you have a 5 and a 6. Well, when I go through my 5 time tables, my 6 time tables, what's common with these two would be, let's see, 5, 10, that'd be 30. I think 30 is the only place they have in common. So I need a 30. So I need a 5 times 6. That'll be a 30. Over here, to make that a 30, that'll be a 6 times 5. Now, let's keep working. Keep finding the common. We have an x to the second power, x to the third. What's going to be common is x to the third. So let's put both of those there, x to the third. And then x minus 7 to the third, x minus 7 to the second. The x minus 7 to the third is going to be the common. So x minus 7 to the third. And over here, x minus 7 to the third. Okay, now let's find out what's different. Here I have a 5. Here I have a 5 and a 6. What's new is a 6. So let's put an extra 6 there for the numerator. Here I have an x squared. Here, just 2 x's. Here I got 3 x's. So that's an extra 1x. So let's put an extra 1x there. I have 3 of these x minus 7s. I have 3 of these x minus 7s, so it's nothing new. I have a 6 here, but there's a 5 here. There's no 5 there. So let's put an extra 5 there. We have 3 x's here, 3 x's there, so it's nothing new. X minus 7, I got 2 of them there, but 3 of them there, so it's 1 extra x minus 7 in the denominator. So we'll put an extra x minus 7 in the numerator. Now, we can put everything together. Okay, the common denominator will be 30 and x to the third power and an x minus 7 to the third power. Okay. And if I multiply this, 4 times 6 times x will be 24x. And then over here, distribution, because it's to the first power, we're going to multiply both of these times x. So a 1 times 5 times x, well, I got my plus. A 1 times 5 times x is going to be 5x. And we'll distribute here to the negative 7. So a 1 times 5 times a negative 7 is going to be a negative 35, I believe. Okay, and we're mostly done. We can combine these two. We're not going to do it on this step, but just know that this is not simplified until we combine these two and get a 29x. But don't worry, I just want to focus on the idea of you guys finding the least common denominators and finding out what your new numerator should be. So let's go to the next one, number 9. We'll have 4 here and a 2 there. And we have 3x to the 5th power, x minus 2 to the second power. And we have 6x to the third power and an x minus 2 to the first power. Okay, so let's work on getting that common denominator. Now we have a 3 and a 6. When you look at the 3 and the 6 timetables, they look like this. The 3 timetables are 3, 6, 9, and 12. 6 timetables are 6, 12, 18, and 24. And what they have in common is actually 6. So 6 is the common denominator. So we want this 3 right here to be a 6. So we're going to multiply, oh, forgot the 4 and the 2. So we're going to multiply this by 2. We have an x to the fifth and an x to the third. So x to the fifth is going to be the common. And we have a x minus 2 to the second power and x minus 2 to the first. This is going to be your common. X minus 2 to the second. All right, let's go here. We have a 6 here. Your LCD was going to be 6. So it's going to be basically 6. And there's no difference. Yeah, we'll just keep it 6. We have an x to the third here. Oh, sorry. We need an x to the, I forgot to write everything down. X to the fifth, x minus 2 to the second power. Okay, so the difference here is from x to the third to x to the fifth is 2 x's. So x squared. The difference between the x minus 2 to the first and x minus 2 to the second is there's an extra x minus 2. So let's put an extra x minus 2 there. Okay. Now we can get one denominator. Okay, the 3 times 2, that's a 6. So that's your denominator here. Then x to the fifth. And then your x minus 2, we need 2 of those. Okay. All right. Here, that's just a 4. There's nothing extra there. I'm sorry, there is something extra. Because I put a extra 2 in the denominator, I need an extra 2 in the numerator. Sorry. I have 5 x's, 5 x's. 2 of these x minus 2's, 2 of these x minus 2's, so there's nothing extra there. Okay, so I got all my extra now. So I got a 4 times 2, and that makes an 8. And then the plus sign. So 8, and then the plus sign. Over here, I need distribution. And this might be a little hard to see, so I'm going to write this down so you can see my distribution. I have a 2x squared with a x minus 2. So my distribution is going to be this. It's going to be the 2x squared times the x. 2x squared times the x will give me 2x to the third power. When I distribute my 2x to my negative 2, this is going to be 2x squared times a negative 2, which is going to end up being a negative 4x to the second power. And we're done.